Kamath, Mekeni, Tukika. Allow me to guide you in learning the different concepts and skills in Mathematics 9. I am Teacher Andrew, your soulmate. For our warm-up exercises, let us refer to the situation and then we give what is asked in each item. Near 1, observe that the y-coordinate of an ordered pair in a set of ordered pairs can be obtained by decreasing the square of the x-coordinate by 2. Item number 1, Karel said that the relation between the x-coordinate and the y-coordinate in the set of ordered pairs can be expressed by the equation y is equal to x squared minus 2. Kale said that equations can also be used to represent quadratic functions. Pick the letter of your answer. A. Only Karel is correct. B. Only Kale is correct. C. Both are correct. D. Both are not correct. Which letter did you pick? If you picked C, you are correct. Let the y-coordinate of the ordered pair be represented by the variable y and the x-coordinate be x. By translating the verbal sentence, the y-coordinate of an ordered pair in a set of ordered pairs can be obtained by decreasing the square of the x-coordinate by 2 into an equation. We have y is equal to x squared minus 2. So, Karel is correct. Kale is also correct because aside from using table of values, equations can also be used to represent quadratic functions. Item number 2. Angelica said that when x is 3, y is 7. Wilmel said that when x is negative 2, y is negative 6. Pick the letter of your answer. A. Only Angelica is correct. B. Only Wilmel is correct. C. Both are correct. And D. Both are not correct. What letter did you pick? If you chose A, then you are correct. Let's construct a table of values. Based on the set of ordered pairs, we see that when x is negative 1, y is negative 1. When x is 0, y is negative 2. When x is 1, y is negative 1. And when x is 2, y is 2. Now, when x is equal to 3, y must be equal to 3 squared minus 2, and this shall result to 9 minus 2. And therefore, y is 7. Indeed, Angelica is correct. Now, when x is negative 2, y must be equal to the square of negative 2 minus 2. And this is equal to 4 minus 2. And the result is 2. Hence, Wilmel is not correct since she gave the wrong value of y when x is negative 2. We can also represent a function through its graph. When we plot each ordered pair indicated in the table of values on the Cartesian plane and then connecting the points to form a smooth curve, the graph of the function y is equal to x squared minus 2 should look like this. This is a U-shaped curve called parabola. Being the graph of a quadratic function, a parabola opens upward or downward. Recall that a quadratic function is of the form y is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The graph that we see opens upward. This is because in the function that is represented by the equation y is equal to x squared minus 2, the value of a, the coefficient, in the quadratic term x squared is positive. A parabola has one turning point. This is either its minimum point or maximum point, and this is called the vertex. In the graph, we can see that its vertex, its minimum point, since the parabola opens upward, happens to be the function's y-intercept, the point at which the parabola touches the y-axis. all quadratic functions have y-intercept. This is obtained when x is set to 0. Hence, the value of the constant term or the coefficient c in the function is its y-intercept. In the function y is equal to x squared minus 2, when x is equal to 0, y is equal to the square of 0 minus 2, or simply negative 2. It means that the y-intercept is negative 2. It is a point on the y-axis that can be described by the ordered pair 0, negative 2. The parabola also touches the x-axis. The point or points on the x-axis that a parabola touches are its x-intercepts. X-intercepts are obtained by setting the value of the function to 0, hence producing a quadratic equation in standard form. So, depending on the nature of roots of this quadratic equation, a quadratic function can have two distinct x-intercepts, one x-intercept, or none at all. When the value of the function y is equal to x squared minus 2 is set to 0, the equation produced is x squared minus 2 equals 0. Solving for x in this quadratic equation means identifying the x-intercepts of the function. So x squared must be equal to 2, and this means that x is equal to positive or negative square root of 2. To plot these on the Cartesian plane, we shall convert each to decimal. You may use your calculator. When rounded to the nearest thousandths, the x-intercepts of the function are
approximately positive or negative 1.414.
Expressed as ordered pairs, the x-intercepts are 1.414, 0 and negative 1.414, 0. Let's have more examples of equations that can describe quadratic functions and their corresponding graphs. Look at the graph of the equation y is equal to 3 multiplied by the square of the binomial x minus 4 minus 5. The next graph is for the equation y is equal to negative 3 multiplied by the square of the binomial x minus 4 minus 5. Another graph that you will see represents the equation y is equal to 1/2 x squared minus 3x plus 1. The next graph represents the equation y is equal to negative 1/2 x squared minus 3x plus 1. Another graph that you will see represents the equation y is equal to 2 times the binomial x minus 4 times the binomial x plus 3. And the last graph represents the equation y is equal to negative 2 times the binomial x minus 4 times the binomial x plus 3. You see 6 parabolas, 3 of which open upward while the other 3 open downward. Do you know what determines the direction of the opening of the parabola? Let us compare the equations for the parabolas that open upward with the equations for the parabolas that open downward. In the equations, y equals 3 times the square of the binomial x minus 4 minus 5, y equals 1/2 x squared minus 3x plus 1, and y equals 2 times the binomial x minus 4 times the binomial x plus 3. The leading coefficients or the values of a are 3, 1/2, and 2 respectively. They are all positive. Hence, the direction of the opening of the parabolas is upward. Now, in the equations, y equals negative 3 multiplied by the square of x minus 4 minus 5, y equals negative 1/2 x squared minus 3x plus 1, and y equals negative 2 times the binomial x minus 4 times the binomial x plus 3. The leading coefficients or the values of a are negative 3, negative 1/2, and negative 2 respectively. They are all negative, hence the direction of the opening of the parabola is downward. At this point, let's complete the table of values that represents the graph of the quadratic function. This is an example of a parabola that opens downward. It means that the value of the coefficient a is negative. Thus, it has a maximum point, its vertex, which appears to be the point described by the ordered pair -1, 8. Hence, when x is -1, y is equal to 8. The parabola touches the x-axis at 2 points, described by the ordered pairs -3, 0 and 1, 0. Hence, when x is -3 and when x is 1, the value of y is 0. The parabola touches the y-axis at 0, 6. Hence, when x is 0, y is equal to 6. And the parabola also includes the point described by the ordered pair -2, 6. Hence, when x is -2, y is equal to 6. What equation describes this graph? Let's use the intercept form of quadratic functions given by y equals a times the binomial x minus r times the binomial x minus s, where r and s are the x-intercepts of the function and a is the leading coefficient or the coefficient of the quadratic term. We already identified the x-intercepts of the function a while ago, and these are -3 and 1. Hence, we have the equation y equals a times the binomial x minus -3 times the binomial x minus 1, or y is equal to a times the binomial x plus 3 times the binomial x minus 1. We now solve for a by plugging in the values of x and y. Where do we get these? Let's look at the table of values. We have 3 ordered pairs to choose from. Ordered pair -2, 6, ordered pair -1, 8, and ordered pair 0, 6. Allow me to use the ordered pair -2, 6. This means that when x is -2, y is equal to 6. Let's plug in these values in the intercept form of the function. So we have 6 is equal to a times the quantity -2 plus 3 times the quantity -2 minus 1. Therefore, 6 must be equal to a times 1 times -3, and 6 must be equal to -3a. By dividing both sides by -3, we get that a is -2. Hence, the equation can now be rewritten as y is equal to -2 times the binomials x plus 3 and x minus 1. Expressed in the form y equals ax squared plus bx plus c, the equation will become y is equal to -2x squared minus 4x plus 6. Now let's sketch the graph of another function, which is y equals x squared plus 4x minus 7. The value of a is positive. Hence, the graph of the function is a parabola that opens upward. Recall that the value of the coefficient c in a quadratic function is its y-intercept. Hence, when x is 0, y is -7. Say, we put 0 as the middle value of x in the table, and we would only need 4 more values of x. Let's try using -2, -1, 1, and 2 as the other values of x we will use to generate 4 more ordered pairs. When x is equal to -2, y must be equal to the square of -2 plus the product of 4 and -2 minus 7, and the result is -11. When x is -1, y must be equal to the square of -1 plus the product of 4 and -1 minus 7, and the result is -10. When x is 1, y is equal to the square of 1 plus the product of 4 and 1 minus 7, and the result is 2. When x is 2, y is equal to the square of 2 plus the product of 4 and 2 minus 7, and the result is 5. So we have 5 ordered pairs to plot on the Cartesian plane. Compare your work with mine. Look at the Cartesian plane. If we are going to connect the points using a smooth curve, it would appear as if it is a half parabola. This could mean we have to extend our table of values to include more values of x. And looking at the plotted points, it seems that we need to use more negative values of x. Well then, let's use -3, -4, -5, and -6. When x is -6, y is equal to the square of -6 plus the product of 4 and -6 minus 7, the result is 5. And when x is -5, y is equal to the square of -5 plus the product of 4 and -5 minus 7, the result is -2. When x is -4, y is equal to the square of -4 plus the product of 4 and -4 minus 7, and the result is -7. When x is -3, y is equal to the square of -3 plus 4 times -3 minus 7, and the result is -10. Let's plot these additional ordered pairs on the same Cartesian plane. When these points are connected, the parabola that corresponds to the quadratic function is sketched already. Did you notice that the parabola touches the x-axis at 2 points? It's not easy though to determine what these x-intercepts are by just looking at the graph. We'll use the function and set it to 0, then solve for x. X squared plus 4x minus 7 is equal to 0. And by completing the square, we have x squared plus 4x equals 7. And then we add both sides by the square of the half of the coefficient of x, which is 4 in this case. So we have x squared plus 4x plus 4 equals 11. And therefore, we have the square of the binomial x plus 2 equals 11. And this means that x plus 2 is equal to positive or negative square root of 11. And x must be equal to -2 plus or minus the square root of 11. Hence, the x-intercepts are approximately -5.317 and 1.317. Lastly, the vertex of the parabola, its minimum point, appears to be the point described by the ordered pair -2, -11. Kagamath, ready your paper and pen. It's Math the Moment! The equation y equals x squared minus 12x plus 45 models the number of books y sold in a bookstore X days after an award-winning author appeared at an autograph signing reception. Item number 1. Construct a table of values and sketch the graph of the function described by the equation y is equal to x squared minus 12x plus 45. 1 minute, go! Time is up. The parabola should look like this. Item number 2. Why doesn't the parabola touch the x-axis? 30 seconds. Go! Time is up. The quadratic function has no x-intercepts since the equation x squared minus 12x plus 45 equals 0 yields imaginary roots. This means that there was no day, either before or after the author appeared at the autograph signing event, that no book was sold in the bookstore. Item number 3. Which part of the parabola should be not considered when looking at how many books were sold days after the author appeared in the event? 10 seconds. Go! Time is up. We do not consider the part of the parabola where x is less than 0, since number of days can't be negative. Item number 4. The vertex of the parabola appears to be the point described by the ordered pair 6, 9. What does this signify? 15 seconds. Go! Time is up. Since the parabola opens upward, its vertex is its minimum point. 6 days after the author appeared in the event, the bookstore sold the lowest number of books, only 9. Stay tuned, Kagamath. We'll learn more about quadratic functions here on DepEd TV. See you in the next episode. Bye!